Okay, so in the second problem, we are dealing with the Poisson processes, and we define stochastic processes n x equals to the certain amount of time from 0 to a certain amount of time, the number of times that a certain event happens, basically like that. And we know that the distribution function of n given T1 and T2 equals that, and T it's E1 T2 minus E1 T1. So the first question I'd like to know the expectation of x, just like that. So we just substitute with the concrete form of x, and we get that. And there's a little bit trick. There is some technique in the summation, and we could just simply multiply k into the denominator, so we get it's the factorial of k minus 1, and we could just suppress k should be start from 1, and the first term k equals 0, it's 0 anyway, because that time the k equals 0. So when k is 0, the denominator is 1, but the k is 0, so the first term actually is 0. We just consider from the second term. That is the term where k starts from 1. And we do some trick here, and we could just substitute k. We'll substitute the k minus 1 in with r. So we just substitute the dummy variable, and we will not change the result. So we substitute k minus 1 into r, and we get r from 0 to infinity, and it's like that. And the denominator should become r, the factorial of r. But look at the denominator. When we substitute lambda t to k to lambda t to r, we actually there should be another extra lambda t. So we just put them out of the summation. It's not summation anyway. So this is just simply is this like the expression of the Poisson random function? We can actually compare here. They're actually identical. Just the difference of the dummy variable. One is k and the other is r. So this summation should be 1. So our final answer should be lambda t. Okay, the third question. We need to calculate the autocorrelation function. Simply you just write the form, and there's actually a dual summation. There's a dual summation. So one is over k1, the second is over k2, and one is with the parameter t1, the second is with the parameter k2. And because these two summations just separate, they just contain different variables. They are formed as the form of a product. We could just write them as two products. We could just calculate these two dual summation into the product of one summation. And this one is about k2, and this one's exclusively about k1. So we just separate the whole term into two parts. So in each part, this is just the expression form of the expectation of x1t and x1t1. Sorry, xt1. And the second is just this is about xt1, and this is just about xt2, the expectation of xt2. So we could calculate them separately, and then multiply the first with the second. So we get the final answer of lambda squared t1 t2. This is just actually the expectation xt1 and t2. And when we look at that, we actually see this is not a WSS, because the expectation of xt it's not a constant. It's actually a function of t.